Hi students, welcome to the science class. In last session, we discussed about acceleration, uniform acceleration and non-uniform acceleration, and also we solved some of the problems on acceleration. In today's session, we are going to study about the graphical representation of the motion. In that chapter, we are going to study distance time graph and also velocity time graph. What is this graphical representation of motion? In simple words, we are going to represent a motion of an object in terms of a graph. We are going to represent a motion of an object in terms of graph by using distance time graph and a velocity time graph. So now study what is a distance time graph. The distance time graph is nothing but the representation of motion, that is the graphical representation of motion. The graphical representation of motion, graphical representation of motion in terms of distance and time. What is distance time graph? It is nothing but the graphical representation of motion in terms of distance and time. What we are going to do here is we are going to take here distance along y-axis, and time along x-axis. What we do here, see, we are going to represent a motion of an object in terms of distance time graph. What we are going to represent here is we get a curve. That curve represents how much distance covered by an object, how much total distance covered by an object, in how much time it will be covered an object. We can get the information by the graph. Then that graph is known as nothing but the distance time graph. The representation of motion in terms of distance time, the graphical representation of motion in terms of distance and time is known as distance time graph. See, listen here, if you consider in your graph book, we are going to take two axes, that is x-axis and y-axis. Along the y-axis, y dash, we consider distance, and along the x-axis we consider time. I am considering here one example for the graphical representation of the motion. So assume that a car moves with a uniform velocity or a uniform speed. Now I am taking here a car moves with a 0 seconds, it covers 0 distance. After 10 seconds, it covers 20 meter. After 20 seconds, it covers 40 meter. After 30 seconds, it covers 60 meter. After 40 seconds, it covers 80 meter. After 50 seconds, it covers 100 meter. This is the data of a car. This is the data of a car which moves with a uniform speed. So now we are going to represent this uniform motion of a car in a graph. See, first point, time along x-axis, distance along y-axis. At that time 0 second, the car covers 0 meter of distance. At the time 0 seconds, it covers 0 meter of distance. Mark the point on the graph. And next, after 10 seconds, the car covers 20 meter. After the 10 seconds, here is in the seconds time. After the 10 seconds, it covers the distance of 20 meter. 20 meter is here. So mark the point is here. The next, after 20 seconds, it covers the distance of 40 meter. After 20 seconds, it covers the distance of 40 meter, mark the point. And after 30 seconds it covers the distance of 60 meter, mark the point. And again finally at the 40 seconds it covers the distance of 80 meter, and at the 50 seconds it covers 100 meter. And join all these points, we get a straight line. This is the graphical representation of the car according to the given data. Have got understood? See here, the graph represents here the slope is a straight line. This straight line represents uniform speed. The car has a uniform speed. Is it clear? What is meant by the distance time graph? The graphical representation of the motion in terms of distance and time is known as distance time graph. In the distance time graph, along the y-axis we take distance, along x-axis we take the time. So by the given data we are going to represent the motion of the car in terms of graphical representation. Then another one, that is velocity time graph. What is velocity time graph? Similarly, what is velocity time graph? The graphical representation of motion of an object in terms of velocity and time. See, what is velocity time graph? It is also the graphical representation of a motion of an object in terms of velocity and time. What happens here? In this case, we are going to take along y-axis velocity. We are going to take velocity along y-axis and time along x-axis. In the distance time graph, we take distance along y-axis, time along x-axis. But in velocity time graph, we take velocity along y-axis and time along x-axis. So, and one example here, and this data gives the change in velocity of a car. According to this, we have to draw graphical representation of that car. Here in 0 seconds it has the 0 meter per second velocity. After 1 seconds it has 5 meter per second velocity. After 2 seconds it has a 10 meter per second velocity. After 3 seconds it has 15 meter per second velocity, and after 4 minutes it has a 20 meter per second velocity. So we are going to represent now the graphical representation of that motion of that car. Here at 0 seconds it has 0 meter per velocity, therefore the car is here at the 0. Next, after 1 second it attains 5 meter per second velocity. After 1 second it attains 5 meter per second velocity. That is here. And after 2 seconds it attains 10 meter per second velocity. The 10 is here. After 3 seconds it attains 15 meter per second velocity. Again along 3, 15, the 2 points meet here. You have to make the points where that two lines of the graphs meets. That is, one line it is coming from the 1 second and another one line is coming from 5 seconds. That will be meet here. We have to make a point at that point. Second one, similarly, last point, after 4 seconds it attains 20 meter per second velocity. 1, 2, 3, 4. So join all these points. This graphical representation represents the motion of the car in terms of time and velocity. So once again, what is velocity time graph? The graphical representation of the motion of an object in terms of velocity and time. The graphical representation of a motion of an object in terms of velocity and time is known as velocity time graph. Okay, next the VT graphs and DT graphs. DT graphs means distance time graphs and VT graphs means velocity time graphs. These distance time graphs and velocity time graphs, the graphs we get represents some important things. What are those? See here. If the slope of the distance time graph is a straight line, if the slope of the distance time graph is, if the slope of the distance time graph, this is along, this is y-axis, this is x-axis, this is distance, this is time. If the slope of the distance time graph, if it is a straight line, it represents object in a uniform motion. This graph represents the object moves in a uniform motion. If we are going to draw a uniform motion of the graphical representation of a uniform motion body, the graph we get in a straight line. This straight line represents objects moves in a uniform motion. When we are going to get this straight line, when we get this straight line, it is confirmed that the object moves with the uniform motion. See next, another next point is, if we get a curved slope in a distance time graph, if we get a curved line in a distance time graph, this is a distance d, this is a time, this is x-axis, this is y-axis. If we get this type of a slope in a distance time graph, this represents an ununiform motion or a non-uniform motion, that is, it doesn't cover equal distance in equal intervals of time. So remember, if we get a curved slope in a distance time graph, it represents non-uniform motion. So if we get a straight line in a distance time graph, it represents a uniform motion. If we get a sloped curve, the curved slope in a distance time graph, then it represents a non-uniform motion. Then next, if the slope of the distance time graph is a straight line parallel to the time axis, see here, I am considering one graph here. This is y-axis, y dash, this is x dash, this is the time axis, this is the distance axis. If the slope of the distance time graph is a straight line, if the slope of the distance time graph, if we get this type of the graph, that is, slope of the distance time graph is parallel to the time axis, this represents object in a stationary. Object is at a stationary. Why? Because I am considering here it is a 5 meter. I am considering 1, 2, 3, 4, 5, 10 seconds. When the 0 seconds, the object is at 5 meter. It covers the 5 meter distance. After 1 second also it is at the 5 meter. After 2 seconds also it is at the 5 meter. That is, this parallel curve, this is parallel slope, represents the object is at a stationary. Once again I am repeating here, if the slope of the distance time graph is a straight line parallel to the timeline, if the slope of the distance time graph, it is a straight line, should be a straight line, and if it is parallel to the x-axis, that is a time axis, that represents object is at a stationary. Then next, another one, if the graph of the velocity time graph is a straight line, if the graph of the velocity time graph, now I am considering velocity time graph, not a distance time graph. Now along y-axis velocity, along x-axis time I have taken. See, if the graph of the velocity time graph is a straight line parallel to the time axis, it is a straight line and parallel to the time axis, this represents object in a constant velocity. See, if the slope of a velocity time graph, it is parallel to the time axis, and this represents the object has a constant velocity. Why? Because now can imagine here, this is the time 1 second, 2 second, 3 seconds. This is the velocity 5 meter per second, 10, 20, 30. At the 0 seconds, it has the velocity 10 meter per second. After 1 second also it has the 10 meter per second. After 2 seconds it has also the velocity 10 meter per second. After 3 seconds it has also 10 meter per second. So when the slope of an velocity time graph, if it is parallel to the, if it is a straight line and if it is a parallel to the time graph, time axis, then that graph represents the object in a constant velocity. Then last one, the total distance calculated by calculating the total area below the velocity time graph. See what it means. If we draw the velocity time graph, this is y-o y dash and x-o x dash, this is the time and this is the velocity. If we get one graph here, this is the one graph OA, this is the one graph, what it says, the total distance calculated by calculating the total area covered below the slope, covered below the VT graph. See what it means, the total distance traveled by an object we are going to calculate by using velocity time graph. How we are going to calculate? By calculating this area. If we get this area, we get the total distance covered by the object. So the total distance calculated by calculating the total area below the graph, below the VT graph. Is it clear? So these are the characters of VT and DT graphs. What they are? Once again I am repeating here. If the slope of the distance time graph is a straight line, it represents object in a uniform motion. If the distance slope of the distance time graph, if it is a straight line, this graph represents object in a uniform motion. Then another one, if we get curved slope in a distance time graph, if we get curved slope in a distance time graph, this graph represents non-uniform motion. And if the slope of the distance time graph is a straight line and parallel to the time axis, if the distance time graph, it is a straight line and parallel to the time axis, this represents objects in a stationary. Object is in a stationary. Then another one, if the graph of the velocity time graph is a straight line, it is a straight line here, velocity time graph and parallel to the time axis, that graph represents the object in a constant velocity. And finally, the total distance covered by an object by using velocity time graph, we are going to calculate by calculating the area below the graph. Area below the graph, not above the graph, area below the graph. If we calculate this area and the given the solution, if we calculate the area of this area below the area of the slope, we get the total distance covered by the object. These are the characters of velocity time graph and also distance time graph. Okay, now we are going to calculate the equation of the motion by graphical method. See how we are going to find out the equation of the motions by a graphical method. Consider an object moves with initial velocity u, and attains final velocity v in time t. See, I am representing here the graphical motion of this an object. An object moves with the initial velocity u. This at here is u. The object moves from the point A towards C. The initial velocity is u and attains the final velocity v. At a time t. From the graph, acceleration of the object is equal to change in velocity divided by change in time. That is acceleration. A is equal to change in velocity, that is the final velocity, it is v, that is OB. OB represents v because object is here. It attains the velocity of final velocity of v meter per second. That is final velocity OB from the graph. OB minus initial velocity AOA. OB minus OA divided by change in the time, that is OE, it is the final time, minus initial time is 0. That is equal to OB is equal to V here, that is the final velocity V, minus OA is equal to U, that is initial velocity, divided by OE is t minus 0, that is t. That is we get acceleration A is equal to V minus U divided by t. Then now consider case 2. In the case 2, the total distance covered by an object, as I discussed before, the total distance covered by an object is calculated by velocity time graph by calculating the total area below the graph. This is the graph of the given object, motion of the object in a velocity time graph. So we get the total distance by calculating the total area below the graph, that is triangle ABC, area of triangle ABC plus area of rectangle OADE. That is the total distance travelled of an object is equal to area of triangle ADC, area of triangle ADC and area of rectangle OADE. Then it is equal to, that is total distance S is equal to area of triangle ADE, that is 1 divided by 2 into base into height, that is AD into DC plus of area of rectangle, that is OADE is equal to side into side, that is equal to base into height, that is equal to AD into DE or OE into DE. That is equal to 1 divided by 2 into AD. What is the value of AD here? AD is equal to OE. Therefore, AD is equal to T into DC. DC is equal to AB. But what is the value of AB here? OB minus OA gives AB. That is V minus U. Plus of OE it is T into DE it is nothing but U. That implies 1 divided by 2 into here V minus U. We know that A is equal to V minus U divided by T, that is acceleration A is equal to, it implies V minus U is equal to this, T will be transferred here, that is V minus U is equal to AT, substitute here, T into V minus U is AT plus UT. It implies S is equal to 1 divided by 2 into AT into T, that is AT square plus UT, that is S is equal to UT plus half AT square. This is the another one expression for motion. And third one, in case 3, the total distance, and also we are going to calculate the total distance covered by an object by calculating the sum of the two diagrams here. One it is a triangle and then one is a rectangle, but also we are going to calculate the total distance of the distance covered by an object by calculating the area of the trapezium OACE, that is equal to area of the trapezium OAC equal to side plus side divided by 2 into height. I am taking one side is here, that is side plus side divided by side plus side divided by 2 into height. I am taking one side here, that is OA plus EC divided by 2 into height. I am taking here OE. Substitutes the value. The OA is equal to U plus EC is equal to here V divided by 2 into OE. OE is equal to T, and S is equal to, here again we have to substitute the value of V here. What is the value of V? Sorry, again we have to substitute value of T. That is, it implies T is equal to V minus U divided by A. S is equal to U plus V divided by 2 into V minus U divided by A. So continue here, the area of trapezium S is equal to, we get V plus U divided by 2 into V minus U divided by A. It implies us, here we take V plus U into V minus U divided by 2A, because the multiplication here it is A plus B into A minus B in the form of A plus B into A minus B, that is nothing but A square minus B square, that is V square minus U square. V square minus U square divided by 2A. It implies us 2AS is equal to V square minus U square. It implies us V square is equal to, transfer this U square this side, U square plus 2AS, or it implies us V square minus U square is equal to 2AS. It is another one expression for motion. So this is the 3 types of motion, equation of motions we can get by the graphical method. On the basis of these 3 equations, in the next session we are going to study some problems. Okay, thank you.